Hello and good morning, and thank you so much for joining me in my shop here. So today, what is today? Today is July 27th. Another cool sunny day here. Well, it's going to warm up, starting out cool and getting nice and warm, but beautiful weather here. I shouldn't even say that because I know so many people are having a tough time, especially here in Canada. There's some bad fires burning, and one of our most famous towns out west has been partially burned by a forest fire. It's really a sad situation. Okay, so with this radio, yesterday I noticed something unusual that I'd like to investigate today. And what I noticed yesterday was the grid on the output tube wants to be a little bit positive for no reason that I can determine, other than perhaps the tube itself, which is what I'm quite interested in. It's possible, I guess, that there's some kind of internal leak in the tube, and somehow the plate charge is getting onto the grid, making it go positive. I'm not really sure. That's why I want to investigate it. So that's going to start off with a round of tube testing. I'm going to test the tube that's in the radio right now, and what tube tester should we use? So this one here, can't really use this for this kind of test because it doesn't have any, well, it does have a leak test here, but you know what, it does have a leak test. So the way this one works is, if I understand it right, and I may have forgotten, if you are doing a leak test and the light comes on, you can then advance this control or unadvance it, and at some point I believe the light goes out, and that tells you what the actual resistance of the leak is. Another tube tester I have, voila, right there. I think this is the one we really should be using for this. This tube tester, you can't see the dial in that. When you're doing the leak test, the pointer indicates the amount of current leaking. So I think it's more sensitive. So this is the guy we'll use to test the 50C5. I'm going to get all that arranged, and we will start. As soon as I get my mouse to work here on my computer. Oh my gosh. Okay, there we go. Okay, let's give this guy a test. Now this is the 50C5 out of the radio, and I don't have this plugged in. Yes I do, just don't have the switch on. There we go. Okay, now the scale here during the leak test becomes an ohm meter. Hopefully you can see that it says 5M, 1M, 50K, 200K. Over here it says leakage. So the more the tube leaks, the farther up the pointer comes, and then we can kind of read off the degree of the leak inside. So we'll see what happens with this tube. Let me double check the settings first. Be a smart idea. So 50C5, voltage set to 47, oddly enough. Signal level 4, the bias is 12H, 12 high. The numbers are 1576G, 1576G, and was that 13 or 43 there? Take a close look at it. $4,300 to be sure. 4,300, correct. And a couple more settings here. 32 on the meter sensitivity, and C for the plate voltage. Okay, here we go. So this is all about the leak test. Here we go. Gotta plug this guy in. What we'll do is we'll do the standard test. We'll see how good this tube is. Maybe it's no good. Now there's a tube called a 50C6. I've never heard of that. 50C5. So to be a good tube, it has to come up to about here on the dial. Okay, we're going to do the leak test because I have to do it before I test the tube. We'll do it quick. And there's no leaks being reported in this tube. And the tube test is way good. Way good. So based on this test, I would not. Now the pointer does come up a little bit, but that's normal in this tube tester. It's the same for every setting except for the 1 and the tube test setting. That's completely normal. Okay, and once again, a really good tube. Wow, it's a really good one. So it appears. Let's try another one. I have a bag with a bunch in it. Which one looks like a 50C5? What about that? Ooh, that's a great big tube. That's not a 50. That's a different one. This looks like this might be a 50C5. C5 with an A on it. I think I should still try different tubes in the radio and see if this effect varies from the with different tubes in there. Okay, this is probably warmed up enough. Here we go on the shorts test. Exactly the same response, and how good is it? It's just as good as the last one. Okay, I want to mix these up. See if we can find another one. In here, this looks like one. C5. Just giving it a moment to warm up. I have nothing to talk about, so I'm quiet. Okay, let's try this one. Not a common thing. Certainly in my tube collection, there should be none that have a serious leak in them, because I should have discovered that during the initial tube testing. The tested tubes, if they're no good, they don't go in my collection here, if you like. But they can be weak and still go in the bag, which is why I need to test them like this. Here we go. Hey, what happened here? This was not very good. I just finished saying I test these before I put them in the bag. What happened? Normal. I don't think this is heating up. Yeah, I definitely got a bad one. Not heating. Okay, a little surprised. Find another one. This looks like this might be one. These old tubes, they get the writing rubbed off or so weak. 50C5. I can see it right on there. Okay, how about you? I'll try this in another tube tester, but well, this guy certainly heated up. Okay, watching the meter. No. leak present, and not as strong a tube, or not quite warmed up yet. Not nearly as strong a tube. Okay. Now, let me just mark these a little bit. Who's taking my marker? Okay, we'll just have to do it as a... So the weak, the good one I will mark with a blue dot. Blue dot. Probably won't persist. Okay. Now, let's stop looking at that. What we're going to do, should probably start with the original tube again. And yeah, I think we'll start with the original tube, which is here, and we'll get the sort of baseline measurement, if you like, and then we'll try these other two tubes, and we'll just see what happens here. You know, I just thought of another possibility. This radio is built with very inexpensive tube sockets, and in the past I have come across one or two radios in which the tube socket itself was shorting out between pins due to a carbon formation in the tube socket, probably from a hot tube, a fairly hot tube in that socket. I encountered that a couple times now. Is that what's going on here? Hey, it's possible. Now, I think they make the tubes in such a way that the sensitive terminals are kept away from each other. Let's just see if there's any truth in that statement. 50C5. 50C5. So look where the grid is here. The grid is pin number 5. Up here, where's the plate? Plate is 7. So from the plate to the grid, you've got this distance. You're going through grid 2. Well, grid 2 has high voltage on it also. So here you've only got a short distance between grid 1 and the screen grid here. Yeah, so not true what I said about... I think probably there's some effort to do that. And not, you know what, I forgot to look at it. This tube has 2 grid pins. Two pins connected to the grid. So it's got 2 and 5. Oh, it's got twice the terminals. Twice the terminals, twice the leak. So over here, this pin is located a fair ways away. Like it's 2 is far away from 7, but 5 is sitting there. I guess they have the 2 pins connected to the grid for the convenience of the radio designers and builders, giving them 2 pins to connect to. And they made use of it in this radio and fooled me a little bit for a while by putting some connections on 2 and other connections on 5. Connection. Okay. Detecting that or figuring that out, I'm not sure. That's interesting. So let's carry on with the tube first, and we'll see if we can eliminate the tube as a possible cause of this effect. What am I doing right now? Let's see. I need to get rid of that screen inset, and I'm warming up a voltmeter, so time for coffee. Okay, I think we're ready here. So the meter you're seeing is, it's just over here. This guy is monitoring the grid voltage of the tube in question. And that, of course, as I mentioned in yesterday's video, that's a very high impedance, input impedance meter, 120 megohms or something like that. So it's not going to draw much current out of the circuit, won't be part of the picture. That's the idea. And that meter takes a long time to warm up, but I think it's warmed up now. Let me just reset the 0, just let me bet here, because a little bit's going to make a difference. We're on the 1 volt scale, so it's 1 volt DC all the way across. And I'll probably have to change scales as we go. Okay, so I'm going to plug in the radio. We're going to turn it on and we're going to watch what happens here. Okay, first with the bulbs. Whoops. Hey, how come nothing happened there? Because the bulb is loose, that's why. Things did happen, Jim. Don't mess up the test. Okay, here we go. Tubes are lighting up. That's good. Now watching that meter. So, in my mind, if there is some kind of, I don't know, injection of electrons into the grid or leak in the tube base, look, the voltage is going down. It's not going up. Huh. Now I have the meter set to positive, so upscale is a positive shift. If I had this on an antenna, we could listen to a radio station while we're doing this. Well, on which one I bet the problem's gone away. Oh, it's starting to move. I think it's heading upwards now. So the meter's own zero. I mean, we're looking just so precisely at it. Its own zeroing could be out a bit. We'll check that in a little bit. Oh, it's starting to climb upwards. So it's taken a long time. What takes a long time? It takes a long time for things to heat up. Take a look at the heating up of the tube socket. I can't imagine it's getting warmed up already, is it? The answer is yes. There's already... Oh, what's all the hot stuff in there? All those white spots you see, they're actually red. Well, there's a lot of stuff here. I'm set to 45. Wait a minute, something not right here. How am I getting... So this resistor's hot, that's not surprising. And the only way to know for sure what you're looking at in this camera I found is to use a blocking technique. I need a blocking sheet. I had something really nice here for that. What happened to it? We'll use this. Blocking. What is that? What are you crackling about? Oh, that doesn't sound good at all. That does not sound good. Okay, so blocking technique here. A little tough. This capacitor, no, it can't be, can it? No. If I block the capacitor, it doesn't change the image. The tube socket is very warm already. This one down here is pretty warm too. What about the rest of them? See, there's just a little bit of heat building up in the rest of the radio, but this particular tube socket has gotten extremely hot. Hey, the leak itself may be generating heat. The darn tubes are in series, so if I pull out the 50C5, they all go off. You know, wow. What? How does the socket get that hot that fast? Everybody's hot down here. Well, I'm willing to bet it's the socket here. Oh my gosh, look at the meter. I haven't looked over at it. Oh, yikes, you've been yelling at me, haven't you? Jim, the meter! Jim, the meter! Okay, next thing we can try is we'll try cooling that down dramatically with a dangerous approach here. A little Mr. Freeze on it. I almost never use this stuff. Where's the blue? Isn't there a... it's missing here. There we are. A little hose. Oh my gosh. I haven't used this. Ooh, definitely got freezy stuff in there. There we go. Okay, so the object is cool it down and watch the meter change. That's the objective. Oh! Oh, that was a little scary there. Definitely made a big difference. It seems to have stabilized at a certain spot there in the meter. What was that? Poof! You're going to break the tube. That staticky sound could be it could be the same thing. The staticky sound could be the same thing. I repeated that. That's how excited I am about this. So we're getting a few things kind of adding up and pointing to it. What I'm thinking is, what if I apply high voltage with a power supply onto the excuse me. See if that crackling goes away again. Oh, I just had to show it in the jar and it went away. If it's that, then flexing it would cause big effects, I would think. Big effects. How much volume have we got going here? Well, we're past the volume control, so it doesn't really matter. Okay, so I'm just tapping on the don't see anything happening at all. I'm going to try to put some twist into it here, or can't get it. Anything happening on that meter? Is it slowly going up? I think it is. So the grid connections right here, it would be most sensitive right around the grid connection. And the meter is going up, isn't it? Is that because the socket is warming up again? But there's no... There doesn't seem to be any mechanical response here at all. Wiggle the tube itself, Jim. Wiggle the whole tube. Yeah. Nothing. Ooh, that certainly says nothing happening there at all. Let's cool it down again. See what happens. That happened. That happened. You bad tube socket, you. Okay, we need to continue with the alternate tube test. So we're gonna we certainly see how this operates with the original tube. We need to put an alternate tube in. Let's see if I can get this out. Oh, I wiggled it around. I left it on a pretty questionable angle. Hot stuff. And we'll pick the one with a very similar operation on the, or very similar result on the tube tester. Okay, back on. What kind of temperature we're still got in there. Things are still warm. Not nearly as warm though. Whew. It's too bad. I have a lot of trouble showing this. So here comes the static again. The meter is showing nothing. Meter is showing a 0. Oh, let's go down to 1 volt. Okay. Took a while last time. It'll take a while this time again. That definitely sounds like something breaking down. Electrical breakdown. The meter's on its way up. Very, very small amount. Now, is that my imagination or is it jumping around? With the static, it is, isn't it? Oh, yeah. But it's not going up. Or is it? So this radio is of the age where it could have a very serious problem in its IF transformers called silver mica disease. That could be what we're hearing. It's very distinctive of silver mica disease, but a lot of things sound like that. It could be a resistor. Even resistors that are failing can sound like that. Inside tubes can generate sounds like that. Talking about it can make it go away. Oh, it came back. How's the meter doing? The meter's not going up. See, maybe two different problems going on here. Could be there was this grid thing going on, maybe because of the last tube, but there's also this other thing going on that we're listening to, which I have no really good reason to think it's this tube socket. Let's go poking while we're listening. We're waiting for the meter to go up. This kind of static usually doesn't respond to poking. You know, it could be the band switch too. Yeah, could just be the band switch. That's phono. Oh, that's interesting. I put it on phono, and the sound is gone. I turn it up a bit. Well, okay, a lot of things are being learned here. One, the tube voltage test is not going crazy. We only have 108 volts. I didn't put it on full. Let's just raise it up. Shouldn't make much difference, but it is going up a little wee bit. Let's just keep it going here. Back to radio. Oh my gosh, I got the volume turned up full. Where's the crackling? Turn this down, you get a bit of a hum, which goes away as you turn it up. That's interesting. So when you turn it down, you're basically grounding out the feed to the triode. Isn't that what would be happening? That's up full. We're hearing some radio sounds from the receiver. Where'd that static go? And the voltage is not going up over here. It's just a tiny amount. Oh, Jimmy, don't. Jeepers creepers. So, ooh, could be the volume control. Who's crackling? No, not the volume control. Even if it is a little bit crackly itself. I don't think it's the band switch either. I think it's a component problem. Yikes. Well, we've had this operating for quite a while now, and there's really been no rise on that voltage except a tiny amount. So that's on the 1 volt scale. You're looking at, 0.01 or something like that volts. And you know what? That could be a zero problem. Let me disconnect the meter. Oh, it's going down, is it? It's a slow poke. Connect it back up. Let's go back to the other tube. We must go back to the other tube now. Finish off the tube experiment. Seems to be the tube that's doing it. And this crackly noise is another issue. The crackly noise goes away when you turn phono on. What you're doing is you're turning off. Come on out of there. Holy smokes, that's hot. What you're doing is you're turning off the radio part of the radio. That must be where the crackling's coming from. That's a bad sign. See the type of transformers here are the kind that often have these capacitors in them that fail, and they're integral to the structure of the coil frame or the coil form inside that can. And in the long run, they all do this, it seems. Okay, what did I do here? So I've put in the other tube. I did do that, didn't I? Yes. I was talking, so you never know what I'm actually doing. Now, we're good. Away we go. Okay, tube's lighting up. Now we're going to watch that meter again. The socket must still be hot though. The actual temperature, I never actually said the actual temperature of the socket. Right now is 44 degrees. The hottest part. This other socket down here, 50. A little resistor in between, 47, and then this one right here. Gonna be a similar temperature, all about the same thing, 50, all around the same temperature. How's that meter doing? Meter's going the other way. So I'm going to stop and go have some coffee and come back. That's what I'm going to do. So you can take a break too. No, you can't. Oh, I was only gone for, well, a couple minutes really. So that you can see it going up right now. So there you are. I think that proves the tube is causing this positive grid effect. And I gotta guess it's because of a leak inside the tube. Even though we couldn't detect it on the tube tester. At least the tube tester I tried. Oh boy. Well, I guess we want to get this tube out of here, and I guess the basic idea is that this tube is no good in this radio. What I'm wondering is this the same as biasing the tube? Is that the same thing? I mean, I guess it must be. Also, there must be a pretty heavy current flowing here to do this. In terms of like a grid current, it's a pretty heavy. I mean, it's not heavy as currents go, but because there's a resistor there bleeding the charge off to ground, so the charge must be replenished through the tube leak. Or it'll have to be, some kind of substantial leak, and we're getting up close to 3 volts across 500,000 ohms. Okay, I think I've seen it. I think I have seen it. The crackling thing really has me worried. How do we actually determine if it's coming out of those transformers? Good question. I think maybe that's for tomorrow. For today, what I've learned is this effect, which I've seen in another radio, at least one other radio. I've probably seen it more and never paid attention to it. This effect is really due to a tube problem. Whew, hot tube. And we have to do this one more time, do we? Should I put the weak tube in? So this one with the blue dot, if the blue dot is still on it somewhere. This is the good guy. So we'll put the good guy there. This is the original. Whew, it's hot like heck. Don't touch that. Don't touch that. The tubes have a rating for the temperature of the glass. You can find it in the tube manuals. They'll tell you how hot the glass will get. So we're going to put in the third tube just for fun. Just for fun and excitement. That's the good tube. And there's the third tube. Let's go. We're all set to go, so why not? First of all, I'll check and make sure. Yep, tubes are lighting up. And we'll let her sit there and do that while I think I have to put more coffee in my cup at this point. Okay, it's only been, I don't know, 2 minutes maybe, and look at that. Voltage going up. So I've got two tubes that have shown this effect. One of them tests really good, the original one. The one that's in there now tests with maybe 50% of its goodness gone. This is the one that we're watching right now. I'm on the 3 volt scale on this meter. I didn't put it back to 1, so that's the last tube got up to about here before it kind of settled. Very surprising to me. This is very surprising in that no tubes showed a leak in the tube tester. I gotta get another tube tester out. Yeah, because this must be having an effect on the radio, I would think, and not a good effect. It's almost like the tube is committing suicide by reducing its own bias, and that's going to cause the current through it. Look, it looks like it's accelerating, doesn't it? The current going through it is going to be higher than desirable, even when there's no sound coming out. It's just sitting there. Now, if that's the case, then if there's more and more current going through it, you get more and more bias building up. We should be able to see an effect, a similar effect on the cathode resistor. If the grid bias that we're watching now is causing the tube to conduct more and more and more, then we should see that. We should see the same kind of effect. Okay, this is going higher than the last one. Okay, I'm going to cut it here, and we will try that test. I'll set up some meters here. Look at it. This thing's just gone crazy here. Put the scale way up. I'll get another meter and we'll watch 2 of them. Yeah, let's do that. In the meantime, I do have a cup of coffee now. I'm going to go drink it, or some of it. Okay, so I have 2 meters now set up. So this one is still reading the same thing as it was before, and this guy is now going to read the voltage drop across the cathode resistor. So I think it should be positive voltage the way I have this connected, so it should go upscale. This is on the 30 volt scale. We'd be looking for 8 volts, something like this. Maybe I can put on the 10 volt scale. Let's put on the 10 volt scale. Why is it reading a voltage right now? Let me disconnect it. There is a voltage sitting inside the radio right now. That's curious. That's very curious. This is also a high input impedance meter. That's curious. The radio's not turned on, like it's not powered up. Well, there's a bypass capacitor. Jeepers, you'd think it would be depleted by the cathode resistor pretty quick. Let me just make sure it's going down very, very slowly. Well, looks pretty steady, really. Wow. Where do you get a steady, that's almost 1.5 volts there in a radio that's not turned on. Well, that's a confusing situation right there. It's a cathode resistor. The only thing going on is this capacitor connected across it. Let me short that capacitor out. I'm just going to use a screwdriver here. We'll see what happens. See if it goes to 0. Well, not exactly the right screwdriver. What's that doing there? Okay, so we're going to try to short this guy out here. Boom. Could be a little bit of a boom. Anything happening over there? I'm definitely shorting it. Wait a minute. Now, if I short that capacitor, then there's a direct connection to ground. You know what? This could be an open clip lead. I could have an open clip lead here. I could have this clip lead could be. No. So let me disconnect from the other meter and connect. It's coming out of the radio. It's not coming from the meter. Pretty mysterious stuff here. I don't know how could this possibly be. Let me pull the plug right out of the outlet here. Turn it off. You're just trying anything to make that voltage go away. Is that a 0 problem? No, because I disconnected the meter and it goes to 0. Actually, it goes below 0 a bit. Oh my god. It's a crazy parade we're on here. It's a crazy parade. Let's connect that. That's the 2 meters connected together and now to ground. Still there. Well, you know, a long shot is that this is coming from a bad capacitor that has turned into a battery. This is, you know, fat chance on that too. Well, as so often happens in my shop. What is going on? Let me put a short right across the leads here. They picked the best thing to do it with, but hey, how come it's not disappearing? What am I doing here? Have I got this wrong? Yeah, okay. What am I doing here? Something funny going on. Hold on. Hold on here. I've done something dumb. Yeah, hold on. I've done something dumb. So, this is the probe we're measuring with. He says that's a stupid statement. Yeah, I've clearly lost my mind here. This shouldn't be where it was. This should be here. And this is my mistake here. not a mistake. Problem here is the black lead is confusing me. The black test lead here, because it's black, I keep thinking, oh, that must be ground. It keeps rolling through my head. Okay, I think I've stopped any mistake that might be. The voltage is really there, and it's not going away. Kind of a mystery. Where could that come from? And it's not a small voltage. It's 1.5 volts. This radio is storing energy. How can this possibly be? Let's just move some more knobs here and there and see if anything happens. Oh no, nothing's going to happen. If I pull the tube out, it doesn't do anything. These are all desperate actions here on my part. Where can a voltage come from? It has to come from something. This isn't a very high, this is not so high. This is a 10 megohm input impedance. It should bleed a charge down over time. And maybe it is, it's just going so slow I can't see it. But I put a short on, at least I think I did. Let's try that again. Let's try that again. Because I got quite confused. Okay, I'm going to short right from the test lead of the meter right to ground. That's got to knock it out. Okay, and where'd it go? I disconnected the short, but the voltage isn't. It's returning very slowly. Mysterious voltages everywhere. That's got to be from a capacitor. And so what I'm talking about, and I've done tests to show that this can happen, the capacitor has mixed metals in it, and if you get enough moisture inside there, it turns into a battery. But the battery cannot supply much current. So it can obviously, if this is true, what I'm saying, then it can supply enough current to drive this meter. That's not a tough call, because it is 10 meg input. The consequences of this. Maybe nothing. I don't know. Well, one of the consequences is it's kind of throwing me off here. Let's carry on with the planned experiment. The planned experiment was turn the radio on, watch the voltage go up on this meter, and then see if there's an effect on the voltage drop across the resistor. Let me just double check and make absolutely sure I got these. I don't have this in the right place, I don't think. Oh, wrong meter. Wrong meter, Jim. No, I do have it in the right place. And the ground. I feel so confused. The ground is so simple and I feel so confused. Okay, the ground is the ground. Well, I don't know what to make of that voltage, but we're going to go ahead with the test. Here we go. Maybe it'll disappear the moment I hit the power here. And the radio is on. Here we go. Power coming. Power on. Power is on. Tubes are warming up. Let's get it. Oh. Okay, so that's the bias meter. That's okay. Except the bias has gone crazy. What happened to my meter? Oh! Oh, this is not what I thought. What has happened here? I've not, you know what I did? I'm so stupid, man. I tell you. I can be as stupid as anybody. I'm quite capable. It's one of my strengths, actually. While I'm thinking cathode, I'm looking at the plate. And I pick the plate connection. How dumb am I? I want the cathode connection. And the cathode connection is a little hard to spot. Yeah, pin 1. Okay. Now, the reading I was getting before could have been coming from the power supply, actually. Okay, let's turn this off. Turn this off. And thank God I'm using electronic meters. This is also a battery-operated electronic meter. It has transistors in it, so it's kind of self-protected in that sense. You can't bend the pointer on it. Try as I may. Okay, we'll move this to the correct spot. This is the cathode. Okay, and the meter appears to have lost its zero. Yeah, its zero is off. Way off. Of course, we're up on the 300 scale. Let's go back to the 30, even the 10 scale. We'll leave it on the 30 scale. 30 volts. Hooking it back up. Now we're in business. I think we're in business. I think I've eliminated my mistakes. Okay, once again, power on. Tubes are heating. There's the cathode bias. We think that should go up to around 8 volts. Let's put on the 10 volt scale. We're at 6 volts. Okay, 109 supply volts. Now it's 117 supply volts. So now the idea is to watch this one. As it starts to go up, what happens to this one? The expectation is that this will go up higher and higher as this one goes up. That's my expectation. And we've got this thing up on 100. Come on, Jim. Get with it. That's on the 1 volt scale. And is it on the climb yet? Yes, it's going up. Now what's the other one doing? I'm looking very closely at the other meter. 7.2 is the voltage. Very accurately. 7.2 on here. You've got a terrible parallax problem there. The other meter is going up. Patience, everybody. Yeah, the other meter's definitely going up. Okay, let me read the cathode bias. It looks like it's gone up at just a fraction. You know, like 1 needle width. It's going up though. Let's, I'd say 7.3 now. Okay, the other one's climbing fairly rapidly. In any case, you really, I was going to say you don't want your grid to be positive, but it's relative to the cathode. And the grid is remaining negative relative to the cathode, but what's happening is the input range, if you like, the signal it can handle is getting smaller and smaller. So this is going up a little bit. I'm going to flip to the 3 volt scale here. Tubes generally, the thing generally gets up into this area. So our bias is now 7.5. So I think that you could interpret this as proof that this voltage on the grid is reducing its bias, causing the tube to conduct more, causing the cathode resistor to drop more voltage, causing the bias to be more negative, but not more negative enough. It's a little like there's a damper on the effect. It's a mutual situation here. If I could make this happen quickly, I would, but we have to have patience here. So the grid voltage has gone up about 10%, roughly. That means the grid current has probably gone, or the plate current basically, has gone up about 10% also. We're getting up into the maximum range, although I think this tube just kept going. So it's kind of somewhat compensatory for its own problem, in that it generates a higher cathode drop. It gives it more bias. At the same time, the bias is being stolen by this effect coming from the tube. None of which could be seen in my tube tester. And none of this happens instantly. It takes time. Notice there's no crackling in the radio. And I think that's because I have it on there. Oh, what happened there? What happened? I just looked up and saw the meter move. You know what that is? That's me moving the band switch a bit. Let me switch cameras. You can still see the meters. I was just wiggling this a wee bit. Oh, this guy just shot right over. When did that happen? Is that from this? I'm afraid I can't look everywhere at once. No. It must have just been going up and I just didn't notice it. Hey. Okay, so that's phono. Oh, that's an interesting effect. So that's going phono, radio. First band, second band, third band. Second band, first band, phono. The phono switch may be cutting power off to some of the tubes. That could be rising the B plus a little bit, and maybe setting this off a little bit here. Because it's not really throwing the bias around according to this meter. So something else must be happening. You need another meter. Phono, radio. Where's that static? There it is. Coming from this volume control. No, that static we heard was different from the other static. It seems to be gone. Because it's related to the tube? Oh! Oh! What was I doing there? Mm-hmm. Ow. Ow, 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 ow. Hurt my ears. Band switch. Clean up. Band switch cleanup. Band switch cleanup time. I do not like this product. You cannot see it. I don't know if any of it's getting anywhere. I can't ever see it. Yeah, it's everywhere, all right. Ah, my fingers. Phono, power on. You know, a lot of people swear by this product here. I'm not trying to promote it, and I'm not trying to demote it either. It's a little expensive. I used to just rely on just straight WD-40 for a long time. It seemed to do the trick all the time. Okay, what do we got happening here? We're back to nothing here. 7.5, a little less than 7.5 here. Is that because we're on phono? Yes, it is. So, volume up, danger, 7.5. Sounds better. I like it. Okay, so we're on a radio setting now, right? Yes, we're on a radio. We're on the broadcast setting. Anybody want to come in? Touch the antenna. Yeah, I think it's working. Okay, what am I doing? So we're watching for that voltage to rise again. Why are we doing this? Why am I doing this again? Because I just cleaned the switch. And not that I think the switch has something to do with these voltages. No, that would really cause brain cell injury for me if that happened. No, see, I think that second meter is starting to go up again. Why do you take so long? If it's heat related, then the radio's already warmed up. Why does it take so long to reproduce the problem? So 60 degrees, 70 degrees, 80, I saw 80 in there at one point. Could the band switch be implicated in this? I can't imagine. I think we just have to wait a little longer. Oh, I got this up on 10 also. Let's put her down here. Watch. It's heading back up again, isn't it? Yeah. So this one is slowly rising again. I'm going to put the tube that appears to be good in there. And that'll be the last experiment for today to verify that at least the grid thing is a tube related problem. Okay, pull this out here. Oh, hang on. You can hear all the excitement, but you can't see it. Here's the excitement. Pull her out. Tube which does not exhibit the problem. So I believe. Let's try it out. So there's no tube current, so there's nothing here. Until the tube gets a B plus and starts drawing current, you'll see nothing here. There it comes. So we gotta let this guy run for a while and see if the bias voltage rises. So once again, I'm gonna stop. I have a chance to drink some coffee and we'll come back. Okay, well, as you can see, the far meter is still on 0, and so the grid voltage effect is not apparent with this tube. That's pretty certain now. I think we can be really certain about that. The other thing is, it takes time, as I sort of clued into the fact it takes time. You have to heat these tubes up quite a bit, or for a fair length of time before the problem shows up. That could be why on the tube tester I failed to discover it. I didn't let the tube run long enough. So I have let a tube run long enough now in the tube tester. There it is. Now I know you can't see the let's see if I can do something really kind of lackadaisical here. Okay, sit right here, and there we go. Good. Okay, I made a video error there. I forgot to flip to this camera. So let's look at that again. So there's the original 50C5 in the tube tester. It's been in here for quite a while. Just as long as I've had the radio turned on, and there's no grid voltage appearing in the radio with the good tube in it. With the original tube over here now, and this has been on for getting close to 10 minutes. I'm going to run the leak test and we'll see what happens. Now this particular tester, this Weston tester, has a problem. This model has a problem where when you do the leak test, the meter pops up a little bit. Some of these, the meter will pop way up high. That's a problem. On mine, it just pops up a little bit, so I don't worry much about it. But that little pop-up happens with every tube all the time. There's just no evidence of a leak here at all in this tube tester. Nothing whatsoever. How long should I leave it in there? I mean, it certainly would be showing up in the radio at this point, but not showing up on my tube tester. Huh. Okay. Well, lots of lessons learned here this morning. I'm going to have to spend some time thinking about all this stuff. First, I better turn this off before we get in trouble. Pop! Quite a loud pop there. That's going to be it for today. Think I'm going to leave that tube in there. I'm going to consider these other tubes to be defective and unsuitable for operation, even though they pass the tube tester test with flying colors. I do have some other tube testers. Maybe I'll play around today at some point. I don't know. It's another beautiful day. I should be outside. What am I doing in here? Thanks a lot for watching, and we'll see you tomorrow when I do something. I don't know what.